Hi guys, welcome back to the channel, and today we're going to build an end-fed half-wave aerial. I've built a few before, and I was looking at components to build it, and I found a website called HF Kits. They actually provide a kit with all the parts that you need, and it seemed very convenient to order the kit and avoid having to look up all of the lengths of wire, etc, etc. So I've actually ordered the kit. I believe it was €59. This is an end-fed aerial that will cover the bands 80, 40, 30, 80, 40, 20, 15 and 10 I believe. It can be pushed with an antenna tuner to cover all the bands, I presume, but those are the resonant bands for this aerial. And this is going to involve a 49:1 ratio unun or transformer, and about 23 meters of wire. This will have a coil in it to lengthen it electrically out to 80 meters, so it is reduced from a full-size half wave for 80 meters, but it is a half wave on 40, and then obviously below it's just harmonics of that. So let's take a look at what's in the kit. I'll just mention that on their website, and I'll leave a link in the description. There is a description of how to build this, and at first glance it's excellent. It really does have plenty of detail. It goes through all the steps, and it talks you through a little bit on what parts of the build affect what frequency, etc. So let's take a look, and we have a box here with bits in it. We have a bag with the former for the coil, an insulator, bits of wire, the main run of wire, and we have little cliplets here that will clip the wire into a loop, etc. And then in the box itself, here's the website, by the way, hfkits.nl from the Netherlands. And the gentleman there, I apologise, I can't remember his name, was super helpful, and they use really good parts from what I can see. So again, these are loops to allow you to put a coil or a loop in the end of the aerial. So let's get cracking with all of this. Sorry I don't have a massive amount of space on my desk here. We'll take a look in the box, just see what's in here. And in here we have these little plastic wire ties. We have a bag, again with a piece of wire and some bolts. We also have a bag with what appears to be stainless steel loops, etc. for hanging the box. And we have this nice holder for the toroid here. So this actually bolts into the back of the box and holds the toroid in place. I think that's a really smart way of doing it. Some more wire here, a little bag with the nuts and bolts in, or certainly the bolts and the nuts, yeah. And then we have the toroid itself. This is an FT240 43 mix, which is the best type for using for end-fed half waves that I've tried. So great, we'll get started and see how this goes. I'll be following their instructions all the way through, and as we go along I'll try and talk you through a bit how they work as well. These end-feds are actually what they call an auto transformer, and there's a primary winding and a secondary winding. The primary winding couples with the secondary winding to increase the voltage and impedance. So the number of turns from the primary side to the secondary side determines the actual increase in impedance as a multiple. And the way that this particular one works, to get the 49:1 ratio, we have, let's have a look here, let's just see what it says. I believe it's 2 turns on the primary and 14 on the secondary. So 2 to 14 is a 1:7 ratio, and with the impedance it's actually the square of that ratio. So 7 times 7 is 49. So the impedance at the, here we go, at the far end, I don't know if you can read this very easily, but it's going to be about 2,500 ohms, which is what the feed impedance is at the end of a dipole, of a half wave wire, there or thereabouts. So that should effectively work like an antenna matching unit, or an antenna tuner as they're called, to match the 2,500 ohms at the end down to 50 ohms for your coax and aerial to work, radio to work with. So that's what it's doing. It's literally just multiplying down the impedance to a good match. So let's begin. I'll go through this step by step, and I'll perhaps quieten down and speed things up as we go through the boring bits, if there are any. So the initial step is to drill the box, obviously with the holes here, and let's go through here. So on the other side we're going to be drilling the hole for the actual connector to go in. And I asked the gentleman I dealt with not to have an SO239 but to use an N-type, because they're more waterproof. So mine actually comes with an N-type instead of the SO239. And obviously we're mounting the hardware. One of them appears to be a ground post, ground terminal, and the other one is the loop for hanging it. This is a diagram of the actual match there. So we've got the connector, two primary turns, also together with the secondary turns going all the way round. So 14 of the yellow turns, which is the secondary, and 2 of the primary. You'll notice here as well, it's not 2 turns separate on the primary to the secondary. They're actually both connected to ground here. So it's not like a normal transformer where it's 2 separate circuits coupled with the toroid. They're actually both connected to ground here, so they have a common ground. And initially these 2 turns want to be twisted together as well, a twisted pair. This will help with the coupling to give you a better match. You'll notice here between the positive and the negative, if you like, there is actually a capacitor as well between the positive terminal of the connector and the ground, and this is to help with the matching of the higher bands. So the higher you go in frequency, the more this becomes a short circuit, if you like, and that's going to help keep all of the harmonic bands in line, hopefully, so they all match up with the harmonic amateur bands. So without further ado, I'll get started, and as we go through each part of the build, I'll take pictures and video, and probably do a voiceover talking you through it. Okay, I've just done the first step. You'll notice I've used a stepper drill to drill the hole, and on the very top there's 2 holes to be made. The first one here is a 6mm hole, that's for the hanging loop, and the other one is for the actual antenna terminal. I mentioned this as a ground terminal, actually it's not, it's the main antenna terminal for the antenna wire. And it comes with all the nuts, the washers, etc, so that's great. It's been straightforward so far. I've only just done that bit, but just wanted to show you the process, drilling the hole, poking it through, and then just linking it all together. It would be nice to have a picture that actually give you the order of the washers, etc, a little better than what's there, because it's hard to tell to see if one of the washers is below or above the actual body of the box. There are other pictures in here, but again it's a little tricky to see which one goes where. So I've had a look through all of the different ones, and that's the one thing I can't seem to find, the actual order of the washers. So I don't know if it's written elsewhere. If it is, I'll let you know. But other than that, I'll carry on, and I'll show you the next step. Okay, so I've just drilled the hole at the bottom. I haven't recorded it because it's a bit of a pain trying to hold a great big drill while I'm drilling it, but I've done the hole in the bottom for the connector to go through, which I'm trying to decide whether to do it a little bit bigger so I can actually insert it from the top. And we're also going to drill the holes for the screw as well, so just spend a second doing that. Actually, I'm going to make the hole a bit bigger so it can actually be fitted the other way around, so most of the connector is inside rather than outside. And that just needs one more depth, I think. It actually lists the depth or the diameter as 16 actually, and I have one size short. There we go. So that's just slightly oversized at 16, or slightly bigger than 16, I should say. So hopefully you can see that now goes straight through and will hang nicely. But what I'm going to do is I'm going to take it out and hold it from the top to decide where the holes go. And right, I'll just see if my pen will mark them. If not, I'll just drill them as we go. Let's just hold that in place. No, okay. So I'm going to have to drill them as we go and put a screw through it to hold it in place. So just make sure I'm fairly central on there. That's only for cosmetics. I'm going to hold it carefully in place and then drill it with the small drill bit. And I believe these holes, actually I don't know if it says what the size of these holes should be in the description here. So the main hole is 16mm and the corner holes for the screws are 3.5mm. Okay, fair enough. So I've found a drill bit that actually fits in, so we're ready to go there. It does mention on this one to just do the two opposing corners. So it appears there's enough screws from the description to do all 4 holes, but you can just do 2 holes if you prefer. So I think I'd rather do all 4 just to hold it in place. Could do with something to hold this properly really, but we'll go for it. I have to say these boxes seem to be very good quality. They're nice and thick and strong. Let's see if you can see this in camera. Again, I would highly recommend, if you've got something on your workbench, to hold it in place so you're not got your fingers so close. That would be a good idea. Right, very good. So that's the 4 holes for the mounting ready to go. Back to the instructions. So after drilling these holes, we can find out if everything fits the way it should. Here you can see the result of drilling the holes and tightening the screws. Okay, so he's actually mounted it all together at this point. So we can see at the bottom here it's all put together. We can see the 4 bolts. It looks like there's a washer on this side. I presume there's a washer on the other side, and then the nut. So let's have a quick peek at the kit we've got. This appears to be, let's have a look here, what else have we got? There's several different bags. I'm going to stick to this bag because this... Actually no, there's no nuts in there. Right. This one has bolts and nuts. And these appear to be the same length as well. The bolts on the actual sheet here, I don't know if you can see that, but they do look fairly long. So I presume there's 2, 4, 6, 8 washers, 4 nuts and 4 bolts. And I would say that's what we've got in here. Okay, so I'll just see if we can zoom in on that. So we'll get that out. There's also other components in here. We've got the capacitor, which goes across the feed point, the positive and negative sides. We'll put that back in there. A little bit of cardboard that came from. There's also a loop fitting. We'll put that back in to keep it safe. And so everything else here, I believe, all will mount to this. So on the diagram, I think they do have it mounted from above, so we'll do that now. So we put this in from above. The bolts are going to go through here. So we've got a washer on first. Oops, get rid of some of this dust. So we've got the washer on first. That then goes through the hole. And actually it's quite a tight fit, so I might need to screw that through. In fact, yeah, let's do that. Just going to grab a screwdriver and screw this through. And I'll do that with all 4 just to make sure they're all located correctly before we start bolting anything down. I do see daylight through all of those, so that looks like it's, well, perhaps a little bit off, but close enough, hopefully. Now I've noticed some of these are essentially lock washer types that bite into the plastic, so I'm going to put those on the outside here, and in fact I'll swap over the one I've just inserted. Yeah, that one went in much easier. I'm just going to remove the one I've just put in and put the lock washer on this side. I've just put the standard washer on this side, which I don't believe is right. It's going to want the lock washer this side. Also, this particular corner doesn't seem to be the best fit, so I might need to redo this hole a little bit. So let's get that out, swap that over, and in fact I'm going to put this in a different hole for now. I'll make sure that the others line up and then we can worry about that one. So let's see how these go. Right, let's get that centered. No, okay. I'm going to just widen these holes slightly because they don't line up perfectly. And what I should have done really is drilled one, put a bolt in it, drilled the next one, put a bolt in that, and so on. But with trying to hurry up so it's not boring for you to watch, I think I've misaligned them a bit. So hopefully I'll leave this in the video though, so it's a bit of a learning experience for those who haven't done this before, hopefully. But all I'm going to do is just round off these holes a little bit. They're roughly in the right place. Again, please use a vise for things like this. This is not the safest way to do this. And like most instructions you'll find on YouTube, I think it's a case of do as I say and not as I do. Okay, so let's try this again. Actually, it appears that it's not lying flush. So what we'll do here is exactly as I should have done it in the first place. I'm going to put one in to locate it, like so, and then I'm going to drill the other holes. In fact, I'll try and put more in to hold. No, that's not ideal. Just trying to see how many actually line up well, and the answer is none of them. So again, learning experience for everybody here, and I should have known better. I've done this many times myself, and managed to bodge it. So I'm just re-drilling these holes more accurately so that everything lines up properly. That's one. We've now got two that are lined up, so we're halfway there. That's great. I'll just make sure the other two now are sitting roughly in the right spot. Good, right, I think this is going to line up now. We'll just try this, and I've just noticed I've got three, oh no, that's right, yeah, 3 locking washers, and here's the 4th, that's great. Okay, so that all lines up now. So in future, again, I would recommend doing it one at a time and put bolts in as you go to keep it accurate alignment as you go along. Just have a quick tidy up. And then on the other end, on the inside, we're going to have a washer and then the nut. So I'll put these on one at a time. Now this will be a little bit fiddly because the ones at the back are not easy to get your fingers on. So I'm going to use the 2 at the front first, just to bolt everything down reasonably snugly so that it doesn't move, and then hopefully that will keep the rear ones still for me to screw everything on. Hopefully, anyway. So this one's being a bit funny with me. That's that one. That's that one. Good, right. The rear 2, these are the finicky ones that are a bit tricky to reach. So as you'll probably see in here, where are we? I've done the 2 this side. I'm going to try and get the back 2 now. And it just involves a little bit of dexterity. And what I tend to do is I'll put the nut roughly on, and then I'll turn this end and try different angles so that hopefully as I turn this end, the other end will momentarily line up and suddenly start going on. Like that. So I'm just holding the nut with my finger on the left, and I'm turning the screw on the right, and it's gradually pulling it in, so that's good. Okay, that feels like it's gone all the way down. And finally, the last one here, we'll try and loop that on. No, let's try that again. Now I've tried to mount this connector in the middle of the box, because as you can see there's 2 screw mounting points here for the bracket that holds the actual toroid, so I've tried to make sure I'm clear of those with this particular mounting. No. This is the fiddly bit. Right, let's get back to the previous technique here. So just start screwing this on and hopefully we'll feel it catch. Is that caught? Yeah, it does feel like that's going on. Right, there we go. Great. So these aren't super tight. I've just done it holding it with my finger, but hopefully I've held it tight enough to screw it down where these little lock washers bite into the plastic, and then that does feel solid. That's not coming loose. They're all bottomed out. So yeah, we're onto a good thing, I think. So we'll look at what's next. I haven't tightened these top ones particularly tight, simply because, well, they don't really need to be super tight, but we can always do that later, just in case we need to move anything. Right, the next step in the instructions is to start making the transformer itself. I hope everything's in focus here for you. So the first thing is to fold approximately 15 to 20 centimetres of enamelled copper wire in half. Right. So I believe this is it here. The only other piece is in this bag. However, I think this is a lot more by the look of it than that. Let's just have a quick look. So I believe this is for winding the actual inductor, inductor, the coil, and I believe this is what goes on the transformer. This appears to be all the exterior antenna parts, so I'm fairly sure they are not relevant to this bit. I'm just going to put them aside. So this bit here, so I believe it's saying to straighten this out and fold it in half. This will create two pieces of wire, one long one and one short part. Then twist the material slightly over the first 15 centimetres to hold it together. Make sure not to twist the copper too much, because this might create strange effects in the transformer at a later point. Now take that point to which the two pieces of wire become one and place this on the toroid. Okay, so fold 15 to 20 centimetres of copper wire in half. Now I'm just conscious this piece of wire is far longer than that. This must be maybe 5 or 6 feet of wire. I'm going to take a look at the instructions and see if this is actually correct. So let's have a look through here. Right, it does not specifically say it anywhere, I don't believe. So I'm interpreting this as fold 15 to 20 centimetres of this entire piece. So we're just going to fold a little bit back on itself. Okay, so there we go. I would say that's about right. I've gone a little bit further. So we've got a short piece and a long piece. Twist the material slightly over the first 15 centimetres. So I'm just going to start by twisting this a few times. Okay, just to show you where I've got to, I've used the copper enamelled wire here. I've twisted it to give you a twisted pair. Let me just see if I can focus in on this a bit better. There we go, that's better. So I've twisted, I've folded the wire in half for about 15-20 centimetres. I've then twisted it about a turn per inch to 2 turns per inch, and then I've wrapped it twice this way round, and the actual loop in the end here I've used a soldering iron to heat it up till it melted the enamel off with a bit of solder, and the solder eventually adheres to it, so you know that the enamel's gone, and that's ready to solder to the connector. The connector itself came in the same bag as the capacitor, so we've got the 100 picofarad capacitor here, which I've checked with the new meter I bought. Well, it says about 104 picofarads, which is, I'm sure, close enough. And we've also got this loop connector here, which again, hopefully you can see that, and I believe that's what's going to go on the inside of the N-type connector. So I'll get that done. Oh, I'm not sure who that is. I'll get that done and come back to you.